Carrying on with 19.1, page 281, I'm going to go straight to question 6. I feel I've got to do a few of these really, and they're quite tricky. So I've been told little baby vector A is minus 1, 2. I've been told little baby vector B is 3, minus 2. And I've been told little vector C is 2, minus 1. And that's the background I've got to work with. It says draw a vector diagram for each question. So I've now got to try and do 2b minus a. Let's just do the maths of it first, alright? So 2b means 2 lots of b, which is 2 lots of 3 minus 2, and then I've got to take away vector a, which is minus 1, 2. Alright, so let's just try and do the maths of that. That's going to be 2 lots of 3, that's going to be 6, and then 2 lots of minus 2, minus 4. Then I've got to take away minus 1, 2. Alright, so let's just draw that as a little picture, and we'll get on with it. Let's just change to blue so it stands out, hopefully. Oh, this pen. Right, pen's working. Right, so 6 minus 4, let's just start randomly here somewhere. 6 across, 4 down. So 1, 2, 3, 4, 5, 6, then 4 down. 1, 2, 3, 4. That's that one. Got to have an arrow because 6 minus 4 is that way and no other way. And then I've got to minus 1, 2. Essentially, what I've got to do, I've got to let's take a look. Minus 1 means plus 1, and minus 2 means minus 2. Effectively, I've got to do that, haven't I? So I've got to go 1 minus 2 from that point on. So 1 across, and minus 2. 1, 2. Alright. So that counts for minus a. So arrow there. That's the minus a part. And this part was the 2b part, and therefore I've gone 2b minus a. So 2b across that route, minus a down that route, then just join the ends using this facility, which sometimes works and sometimes does not. And there it is, little arrow, and this is called 2b minus a. Alright, so 2b minus a, 2b minus a direct. Now there is another way I could have expressed it, and I'll try and draw that in a different colour next to it. First we do the 2b minus, do the 2b first, so that's not going to change, and that was 6 minus 4. Let's use this. 6 minus 4, 1, 2, 3, 4, 5, 6 minus 4 is that. So that's the equivalent of the 2b there. Now, the minus a root could have been expressed as before, and again join the ends like so, but look at the arrows I'm about to do. 2b is like that in the normal direction, but 8, if you express it as a positive vector, must go in that direction, because a is in fact 2, where's the a? Minus 1, 2, look there it is, minus 1 to the left and 2 up, and this final vector would still be 2b minus a in that direction. So watch this, I've gone down 2b and then against the normal a direction, hence the minus a. So it's 2b positive minus a against the arrow shown in the diagram, and so I've gone, from there to there, and I've reached my destination. Net effect, it's still 2b minus a. That's a different way of expressing the vector diagram. Either use the minus a as seen and put the arrow in the direction in which we've calculated it originally, or you stay true to the original vector, minus 1, 2, but flip the arrow. Alright, so that's 2 ways of doing it. That's quite tricky, isn't it? I think I'll do another one on the other page. And I've got to do a plus b plus c. Alright, let's just write it down quickly. I've got to do a plus b, and I've got to add on a c. Now, a originally was minus 1, 2, B originally was, well, still is 3 minus 2, and C is 2 minus 1. So I've got to go one after the other. Let's try and do it in one hit or so. Right, let's go on red. Right, let's start here. I don't know what it's going to end up to. I've done it. Minus 1, 2. So minus 1, 2. That's A. Got a little A there. Then I've got to go 3 minus 2. Fair enough. So from where I left off, 3 minus 2. 1, 2, 3 minus 2. Well, that'll be there. And of course, my A is now in the way, isn't it? Let's just rub it out. Pen working now. And now I've got to go C, which is 2 minus 1. So 2 along and 1 down. And there it is. That's the 3 different vectors. A, B, C. So, join the ends. A plus B plus C is like going from A to C, the end of C directly. So just join it, and that's that vector done. Teachy little thing, isn't it? That vector is called, let's just label it in blue so it stands out, A plus B plus C. Okay, we went up the A route, down the B route, and down the C route. It's like going from A to C directly. Alright, that's that one done. And let's try and do this last one, which looks really tricky. I'll try and make it fit somewhere. I've got to do minus A, minus B, and then plus an A. Lovely. Well, let's look at this vector here. If that's a regular minus 1, 2, we go minus A, then it's going to be 1 minus 2. And then I've got to take away 3 minus 2. In other words, I'm going to go minus whatever the B is. So go minus 3 and then plus 2. Then I want to add on an A at the end of it. And A is going to be minus 1, 2. So I think I'll just convert this over right now. I'm going to go 1 minus 2 followed by minus 3, 2. Remember, minus 3 and then minus 2 is a plus 2. And then I want to go minus 1, 2. So let's just do that very quickly and try and draw the journey just here. Vector diagram, I like to think of little journeys. Right, so let's just start. 1 minus 2. Start here somewhere. So 1 across, 2 down. Done. That's minus A. I won't label it until it's over, just in case I crash into another vector. So let's just be careful with that. Right, so 1 minus 2. And then I'm going to go minus 3. So 1, 2, 3, and 2 up. 1, 2. That's that one. Better put the arrows on in case I mess it up. So that's that one. And then I did that one. And now I'm going to go minus 1, 2. Minus 1 and 2 up. 1, 2. And there it is. Little arrow. Now I'm going to label it happily. Happily ever after. This pen would just please do its ends. Just review. So 1 minus 2 is that one. So that's going to be minus A. Then I went minus 3, 2, which is actually minus B, isn't it? Then I went positive A, which is A on its own. And that's what I've got. And the net effect is this one, which is minus A plus B plus A. That's what that is. So I went down here, then up the A. Therefore the net effect is to go straight across like that. And that is called, make it stand out in blue, that will be minus A, minus B, plus A. Now again, if I wanted to redo this, just express it as positive vectors anyway, then what I can do is this. Now I've got to try and redraw it. Hopefully that worked fine. Right. That. And then minus 3, 2. That should be joined, of course. And then minus 1, 2. Which is that one. Then join the ends. So if I'm working with positive positive vectors only, A would be that way, B would be that way, regular A would be that way. As you can see, these are parallel in the diagram, and this vector will be, as previously labelled, minus A, minus B, plus A. If you look at it carefully, starting from here, I'm going minus A against the natural flow of one-way traffic, and then minus B, against the flow of natural B traffic, and then plus A. The net effect is exactly the same as the diagram above, but I've expressed it on the diagram using the original positive vectors. And that's the last writing as a single column vector. If I read on from here, I go 6 minus 1, 7, and minus 4 minus 2 minus 6. So the final vector 2a minus b should be 7 minus 6. Let's count. 1, 2, 3, 4, 5, 6, 7. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. That's definitely correct, therefore. Just do this part as well. Add this little lot up. It says plus, so I'm going to do that straight away. Get an answer. Right, minus 1 plus 3, that's going to be 2. 2 plus another 2 is 4. So the horizontal net movement is 4 in the right direction. So 2 plus minus 2, 0. 0 minus 1 is minus 1. So the net move should be 4 minus 1. Now I don't know where that diagram has gone now. Let's have a look. Oh, here it is, 4 minus 1. Starting from here, vector A plus B plus C. 4 in the right direction. 1, 2, 3, 4, and 1 down. That's completely correct. Let's just do the sums for this one. We'll do it over here then. That's going to be, well, that's minus A. I've converted it over into regular bits and pieces, into the negative version of the original vector. So I've got 1 plus minus 3 is minus 2. Minus 2 plus minus 1 gives me minus 3 overall for the horizontal movement. And minus 2 plus 2 is 0. And 0 plus 2 is 2. So the net effect of this vector is to go minus 3, 2. Let's just test it. Let's just start here. So that's where the vector is, minus A minus B plus A. So minus 3, 2. 1, 2, 3 to the left, 1, 2 up. So we've proved from the diagram that works as well. This is question 8 on page 282. It says vector AB is given by minus 2, 4, and vector BC is given by minus 3, 3. Just close it off like that. I've got to draw a diagram of AB, so this is a vector diagram, plus 2 lots of BC. So let's just see what's going on here. If I do a little sum, I go minus 2, 4, and then add on 2 lots of minus 3, 3. Yeah, so I'm going to write it as a single vector first. That's part B. Let's do it now while I'm in the mood. So that gives me minus 2, 4. Then add on, well, 2 minus 3s are minus 6s. 2 3s are 6. So the net effect is to have a vector of minus 6 and minus 2, which is minus 8. And 4 plus 6 is 10. So my final vector, which is AB plus 2BC, as a direct vector, is minus 8, minus 10. We'll have a look, shall we? Let's see what happens. It's just working blue, just for a bit of variety now. Right, let's go minus 2, 4, starting down here. Minus 2, 4, 1, 2, 3, 4. That's that one. Oh, I dropped it, never mind. And that's going to be like that. And that's, what's that? That's minus, sorry, that's just AB, isn't it? Minus 2, 4, yeah, AB. So A is there, B is there. Now I've got to go minus 6, 6. Fair enough. Let's do it. It's minus 6. 1, 2, 3, 4, 5, 6, and 6 up. 1, 2, 3, 4, 5, 6. Finished. So, not perfect. Best I can do. A, B, and that's C. So, please note the original BC vector was minus 3, 3. I've done 2 lots of minus 3, 3. Look at this. 1, 2, 3, 1, 2, 3. It's like a waltz, isn't it? One more time. 1, 2, 3, and 1, 2, 3. That's 2 lots of minus 3, 3. Hence minus 6, 6. Now just finish off the vector. It's like going from A to C direct. Therefore, I pick up this facility and join the A to the C, and there's my final answer. So what have I done? I've gone from A to B to C, or I go straight from A to C directly, and there it is. That's my vector diagram. That was painless. That was good fun. That's it. Oh, by the way, is it truly minus 8, 10? Let's count. Starting from A then. 1, 2, 3, 4, 5, 6, 7, 8. Yep. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, I'm really happy with that. So that's true. And I'm going to say goodbye to section 19.1, and I'll catch you in 19.2 quite soon.